Welcome to the presentation on count ways to build good strings problem. Today we will dive into the problem statement, solution approach and code implementation. Let's begin. The objective of this problem is to count the number of good strings that can be formed under specific conditions. Here's what we are given. 4 integers low, high, 0 and 1. These integers define the constraints of the problem. Now let's understand the rules. A good string can consist of character 0 repeated up to 0 times and the character 1 repeated up to 1 times. The length of the string must fall between low and high inclusive. Finally, we need to output the total count of such strings taken modulo 10 to the power 9 plus 7 to handle large numbers. To solve this problem, we use the dynamic programming approach. Here's the breakdown. Define a DP array DPI which represents the number of ways to build strings of length I. Use a transition formula. Add 0 repeated up to 0 times. Update DPI using DPI minus 0 if I minus 0 is non-negative. Add 1 repeated up to 1 times. Update DPI using DPI minus 1 if I minus 1 is non-negative. Continuing the approach, initialize the base case dp0 equals to 1, which represents the one way to form an empty string. Finally, calculate the sum of all dpi values where I is greater than or equals to low and less than or equals to high. This sum gives the total count of good strings. Now let's look at the C++ code. First, we include the necessary header files and define the count good strings function. We declare a constant mod to handle modulo operations. Next, we initialize a dp array of size high plus 1 and set dpi and set dp0 equals to 1 as the base case. Moving forward with the code, we iterate through each length, updating dpi based on the values from I-0 and I-1. After processing all lengths, we calculate the result by summing up all values of dpi for lengths between low and high. Finally, the result is returned as the count of good strings. Let's understand the code further. The dp array dpi tracks the number of ways to form strings of length I. The transition logic ensures we include contributions from both adding zeros and ones to previously computed lengths. The final summation step aggregates all valid string counts for lengths within the range low, high. To handle large values, all calculations use modulo 10 to the power 9 plus 7, which prevents overflow and ensures correctness. Analyzing the complexity. The time complexity is big O of high as we compute dpi for all lengths up to high. The space complexity is also big O of high due to the storage of the dp array. This approach is efficient given the problem constraints. Here are some key insights from the problem. Dynamic programming is a powerful tool for solving range-based problems. Modular arithmetic ensures we handle large numbers effectively. Proper initialization of the DP array is crucial for avoiding errors. Thank you for your attention. If you have any questions or suggestions, feel free to share them. I hope this presentation was insightful and helpful for solving similar problems.